Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day everyone. Alright, so today we are going to start our chapter 2. Okay, for today asynchronous lecture, we are going to start with chapter 2. Since last week we have completed chapter 1 and I'm expecting you to submit the assignment for chapter 1 by end of this week, Thursday. Alright, so the chapter 2 is limits and continuity. Okay, limits and continuity. Alright, and again, I think this chapter 2 also, most of you might be already studied somewhere in your previous education. Alright, so limits, or in Malay we used to call had, right? Okay, so these are the outlines of the chapter. We have definition of limits, okay, one-sided limits, limit laws, infinite limits of a function and its asymptotes, limits at infinity and its asymptotes, L'Hopital's rule, and continuity of a function. Okay, so for today, perhaps we are going to discuss up to limits, definition of limits, one-sided limit, limit laws, and perhaps on infinite limits and its asymptotes. We'll see, or maybe up to 3 here. I also not sure, because this is asynchronous lecture. I might be going fast compared to if I have a face-to-face class like before. Alright, and there's cartoon kat sini. Okay, I hear a funny joke about limits. Okay, D and E. Okay, I'm not sure because this is synchronous. I tak boleh nak tanya you all. So you familiar with the word D and E here? Okay, what is D and E? Okay, so one of the lecture outcome for today, okay, make sure you know what is D and E kalau you all tak tahu lagi. Alright, so stay tuned. Okay, I might ask you, okay, to define what is D and E at the end of today asynchronous lecture. Alright, okay, so we're gonna start with definition of limits. Alright, so basically what is limits? Okay, limit of a function. Okay, so it is defined here. Suppose the function f is defined for all x near a except possibly at a if fx is arbitrarily close to L, as close to L as we like, for all x sufficiently close to but not equal to a, we write this. Okay, we write this. Limit fx as x approaching a is equals to L. Okay, kalau sebelum let me just explain to you. Okay, you do not confuse limit. Katakanlah we have a function. Okay, we have a function. Kalau saya tak nak guna x approaching a macam ni, let's say I have a function f x is equals to x square, for example. Okay, as simple as this. Okay, then we have f2. Kalau f2 maksudnya this is a function. Okay, this is a function. So f2 will equals to what? 2 square, then you get 4, right? Okay, but when we say limit, maknanya kalau yang ni fx equals to x square, meaning that when x is equals to 2, the value of y or fx is equals to 4. But if I put limit x power of 2 as x approaching 2, okay, meaning that it's just limit as x approaching 2. Bila x approaching 2, it's not necessarily that x is equals to 2. It's just that x is approaching 2 of x square. Okay, of x square. So sometimes this is the same, but sometimes this is not depending on what is your function. We will clarify this more afterwards. Okay, but as of now, saya nak bagi tahu function, when we have a function, limit fx as x approaching a is not necessarily equals to fa. Fa ni apa maksudnya? Maknanya kita substitute x into a kan. It's not necessarily the same. Okay, this is a function but this is the limit of a function. So maksudnya yang ni is just that x approaching a, not x is equals to a. But for x approaching a, there is a possibility that nilai dia sama dengan bila x is equals to a, kita masukkan dalam fx. Hope you are clear about this, alright? So let's have a look at this example. Limit fx as x approaching a is equals to L. Say the limit of fx as x approaches a equals to L. Okay, let's have a look at this example. I think this example is more clear. Alright, we have a function fx equals to x minus 1 over x square minus 1. Kalau like if it is a function, meaning that we choose a number, okay, we'll say that when x equals to 1. So meaning to say this one, okay, we substitute when x equals to 1, f1. So what you will get, class? We substitute 1, x with 1, so we're going to have 1 minus 1, 1 square also 1 minus 1. So what you will get? You will get 0 over 0. You all belajar sebelum 0 over 0 sama dengan berapa? Okay, 0 over 0, if 4 over 4, 4 over 4 is 1. Kan? 5 over 5 is also, 5 over 4 pula. 5 over 5 is also 1. 3 over 3 also 1. Is it also implies that 0 over 0 also 1? No, right? Okay, 0 over 0. This is what we call D and E. So, anyone can guess what is now D and E? Tak bestnya lah, because this is a synchronous. Kalau synchronous, I think many of you can make a guess, right? What is D and E? Alright. So, D and E here stands for does not exist, meaning that the value is undefined for x is equals to 1 to this function. Okay, we don't have such a value when x is equals to 1 for x minus 1 over x square minus 1. By the way, however, okay, alright, so this one, for this function, okay, saya tulis besar-besar kat sini, limit fx kat sini, which is our fx is x minus 1 over x square minus 1 as x approaching 1, okay, kita cari value tadi, when x is equals to 1, we say that it does not exist. However, when it comes to limit, maybe it does not exist. It may have a value. Macam mana nak check? One approach is like this. We use a conventional technique where we are substituting the value where x is approaching 1. As I said here, limit means that as x approaching a number, bukannya x equals to that particular number. Alright, so here we focus when x approaching 1 for x less than 1, or we call this one x approaching x approaching 1 from the left kat sini. Maknanya kita ada satu kat sini kan. Okay, this is the region where x is less than 1 and this is the region where x more than 1, right? So from the left maksudnya x approaching less than 1. Okay, we try to substitute the value for any value x is less than 1. It can be start as small as 0.5, kita tambah lagi 0.9, then 0.99, 0.999, and then 0.9999, and if you want you may continue, but it is tambah lagi 9999, but it's not 1, just approaching 1. Okay, but and then it is less than 1. So as you can see, you press the calculator lah yang ni kan. Masukkan 0.666, 0.5 minus 1, maknanya kat sini kita masukkan value 0.5 ni into x here. 0.5 minus 1 over 0.5 square minus 1. Then you will get this. Same also, saya jam lah yang ni 0.9999. Maknanya 0.999 minus 1 over 0.999 square minus 1. Then you will get this value. Okay, kalau ni pun tambah. So you nampak tak ni the pattern? It is converged to a value. Can you see the pattern here from 0.6667 kalau untuk when x equals to 0.5. Tapi bila x equals to 0.99 dia dah start 0.502513. When x equals to 0.9999 then 0.50025. So it become more closer to what value here? 0.5. Do you agree with me? Okay. And the same goes here. Yang ni kita check for x for x approaching 1 from the right. Maknanya value x tu kita ganti dengan value yang lebih daripada 1 tapi dia approaching 1 from the right. Maknanya value tu lebih daripada 1 sikit. Jangan banyak sangat. Okay. So we start with 1.5 bigger than 1. Okay. So when you replace 1.5 into this function, you get 0.4. Then you reduce the bit level value 1.1. So 1.1 minus 1 over 1.1 square minus 1. Then you get this value 0.476190. It reduce more 1.01. Okay, 1.01 here. Then you get 1.01 minus 1 over 1.01 square minus 1. Then you get this value 0.497512. Dan makin lagi hampir dengan 1, for example here 1.0001. Okay, put in here. Then you get closer to 0.499975. So you can see the pattern here also, it become converge to what value here? Sangat, kalau you bundarkan kat sini dia akan close to 0.5 as well. Faham tak? Okay, it is close to 0.5. So meaning to say yang ni, okay, as x approaching 1 for limit fx as x equals to okay, so here I erase everything tadi, nampak serabut sangat, and I have ni. So maknanya untuk A, the answer that we have here, F1 tadi kita dah try substitute x equals to 1 into this function, then we get 0 over 0 kan. So meaning that the solution does not exist. But kita dah discuss tadi limit x approaching 1 from the left for x less than 1 here is converge to 0.5, and this one limit x approaching 1 from the right means that more than 1 also converge to 0.5. So it seems that it agrees on both sides. Then this limit of x as x approaching 1 does exist, which is equals to 0.5. Okay, so and do we need to substitute like this always, then only we can figure out the answer exists, which is equals to 0.5? Not necessarily. Okay, ni yang paling fundamental punya teknik lah. But there is a way that we can, by looking at the function, okay, we can use some other technique in order to get the answer also 0.5. Alright, okay. Okay. And we may have a look quickly at this example. Okay, let's have a look at this example. I have graph kat sini. Okay, let's have a look at this example. Limit fx as x approaching 2. Mana x approaching 2? Faham kan graph ni everyone? Okay, so you have a graph when sorry. Limit fx as x approaching 1. Make sure you faham jangan confuse. Kat sini dia kata limit fx as x approaching 1 kat sini ni. X approaching 1. Maknanya kita nak tengok what is the value of y or fx as x approaching 1. Kita tengok from both side. Ni kan kat sini x is equals to 1. So we're looking from both side, from the left and from the right as x approaching 1. For this curve, this is y equals to fx ni. So as you can see, as x approaching 1, this curve is equals to 2. Tak ada apa-apa issue. So, it's equals to 2. Sebab kita nampak menghampiri 1 daripada kiri dan daripada kanan is all pointing to 2. Okay. Now, let's have a look. Okay. As this example. Okay. For this example pula, in this example, as x approaches 3. Okay, x approaches 3. Tengok graf ni, as x approaches 3 from the left and from the right, from both sides. Okay, as x approaches 3 kat sini, you see the curve is equals to 4. Okay, is equals to 4. Nampak tak? From the left and also from the right is equals to 4. But does this indicate that, can we say F3 is equals to 4? Can we? Okay, you nampak tak ni ada lubang ni? Lubang ni meaning that F3 does not equals to 4. Dia tak define at S equals to 3. But as x approaches 3, yes, you can say is equals to 4. Tapi yang ni tadi is a smooth ke? Tak ada lubang-lubang. Then you can say that this one F1 is equals to 2. Alright? And then have a look at this example. Okay, example 2 here. Limit fx as x approaching 2. Mana 2? Kat sini 3. Kat sini 1. Ni dah 2. Okay, as x approaching 2. So you can see here as x approaching, again ada lubang kat sini. Okay, from the left and from the right. Okay, pointing to the lubang here. So this lubang is actually pointing to what number? 3. So mean this answer, limit as x approaching 2 fx is equals to 3. Okay, is equals to 3. Can we say that, for this case also, can we say that f2 is equals to 3 class? Ada lubang ke smooth macam ni? Okay, this is also berlubang, meaning that at x equals to 2, it is not equals to 3. But it is undefined sebenarnya. Okay, this one sebenarnya does not exist. Yang ni pun sebenarnya does not exist sebab dia berlubang, is undefined. Alright, okay, that's it for the first part of lecture for synchronous class.